Okay, so now let's talk about infinite limits. So what do we mean by infinite limits? We mean limits where we have an infinite jump and we get a vertical asymptote. So an example we saw last time is something like the limit as x goes to 0 from the right of 1 over x, and we're going to say that this limit is infinity. So let's draw out the picture of this again and see what we mean by this. Well, we know that for this graph, y is equal to 1 over x. The graph sort of looks like this. So indeed, we see that as we approach 0 from the right-hand side, from the positive numbers, this graph gets bigger and bigger. We're taking a small positive number and taking 1 over it, and that's going to give us a huge number, and that's going to become very large. We say it goes to infinity. So another standard example of this sort of behavior, if you've seen the function the logarithm, we know that the limit as x goes to 0 from the right of the logarithm function is going to be equal to minus infinity. And we see that the graph of this, the logarithm only exists for positive numbers, but the graph of the logarithm looks like this. And we see that we have this asymptote going down. It's becoming very large in absolute value but negative, and we say that this guy goes to minus infinity. So these are some nice examples, but the point of what we want to do is we want some tools to determine when a limit is infinity or minus infinity and how we can discern when that's going to be the case. So we want to compute some infinite limits. But there's another phenomenon going on, and that's the following. So if we take, for example, the limit as x goes to 0 from the right of 1 over the logarithm of x. I won't draw that out. You can sort of imagine what it looks like. But what are we going to get? What we have happening is we have these huge function values in absolute value, 1 dividing them, and if you take 1 over a huge number, you get a small number. So this limit's actually going to be 0. What we're going to see is we can sort of play with these infinite limits. We're going to see some examples of when you can say a limit is infinity of minus infinity, but we're also going to have some rules. Like if you take a limit that goes to infinity and take a function 1 over it, you're going to get a limit going to 0, and so on and so forth. It's hard to write all of this down in detail, so let's go through some examples. All right, so let's do some examples. So what can we say? Well, let's just talk about a basic principle. If we have a function that goes to 0 and we take 1 over it, we can expect that to go to infinity or minus infinity depending on its sign. So let's do an example of this phenomenon and see what happens. So let's say we take the following. Let's take the limit as x goes to, let's say, 4 from the right of x plus, root x plus 3 all over x plus root x minus 6. There we are. Okay, so let's talk about what happens here. So this is an example similar to one we've seen before, but we're going to have a problem. We see if we plug in 4, the numerator is going to be fine, but the denominator is not going to be fine. If we plug 4 into this denominator, we're going to get 4 plus 2 minus 6, which is 0. So we sort of expect that this limit should blow up to infinity because we have a non-zero number up top. Up top is going to go to 5, and the bottom is going to go to 0. So I think, without writing out a whole bunch of formalism, I think we can sort of intuit that this limit is going to be an infinite limit. The graph's going to have a vertical asymptote. But the question still is this going to go to plus infinity or minus infinity? We're approaching from a particular direction, and we've seen with the example of 1 over x that this doesn't mean necessarily that we're going to go to plus or minus infinity. We have to figure out which it's going to be. Well, we can do this with a little bit of factoring, at least in this case. These problems can become very difficult, but in this one, a little factoring trick can save us. Because what do we have? We can factor the bottom. And we can say, well, the bottom has a factor of square root of x minus 2 in it, and that's what's going to make this whole thing 0. Indeed, we can factor the bottom as square root of x plus 3 times square root of x minus 2. And now, since this is not 0 throughout our computation, we can get rid of this, and we can turn this thing into just the limit as x goes to 4 from the right of 1 over square root of x minus 2. And now we can see that for x greater than 4, the square root of x minus 2 is going to be greater than 0. So the limit as x goes to 4 from the right of 1 over the square root of x minus 2 is going to be infinity over minus infinity. So I didn't write down some explicit rules here because indeed there's just a lot of cases and it would take boards and boards to write all the specifics, but the idea here is you take 1 over a function that gets very small, that's going to have to go to plus or minus infinity, and then you just have to determine whether it's positive or negative to determine whether it goes to plus infinity or minus infinity. This guy is positive in the region we care about, so it goes to infinity. So we could do many examples with this, but instead what I want to give for now is a caution, and that's that we have a problem. So note, things can go wrong when we have a 0 over 0 or infinity over infinity limit. So what do I mean by this? I mean, suppose we want to compute a limit as x goes to something, let's say 0 from the right, but anything. If you have f at x over g of x, well, we can have a problem if the limit of f and g both go to 0 or both go to infinity. And what do I mean by we have a problem? I mean that we can't say immediately by eyeballing it what it's going to do. Because in the 0 over 0 case and in the infinity over infinity case, we can get all sorts of different examples, sometimes where these limits go to infinity, sometimes when they go to 0, and sometimes when they go to a finite number. Suffice it to say, there's no easy way out of this, and in order to get a handle on infinite limits, you're just going to have to do as many examples as you can. But to make good on my note, let me just give the following few examples. So let's say we have f at x is equal to x, and g of x is equal to x squared. So we know, of course, that the limit as x goes to 0, just either way, but for the right for now, as the limit as x goes to 0 from the right of x is equal to 0, and the limit as x goes to 0 from the right of x squared is equal to 0. But we have 3 different behaviors that can happen in various cases. So consider the following. If we take the limit as x goes to 0 from the right of g at x over f at x, well, this is going to give us the limit as x goes to 0 from the right of x squared over x. But this is an easy limit. This is just the limit as x goes to 0 of x, which is 0. So this is a case where we couldn't use our limit laws because we had a 0 over 0 limit. You can't deal with a 0 in the denominator. But if we work it out, we get that this limit goes to 0. But a different thing happens in the other order. If we take fx over gx, well, this gives you the limit as x goes to 0 of x over x squared. But this is, of course, the limit of 1 over x, which we already talked about is infinity. However, one more case we can talk about is when the functions are the same. So if we have the limit as x goes to 0 of fx over f at x, well, indeed, we know this is going to have to be 1. It's just the same function top and bottom. But this nonetheless illustrates the concept that we can get a finite number from this as well. So suffice it to say, you're going to have to just do some examples here. You're going to have to get the knack. It's a lot of pre-calculus inequality stuff when you have an infinite limit to show if it's plus or minus infinity. But the guiding principle is that if you take a limit and you have something that goes to a finite number over something that goes to 0 in the bottom, you're going to get an infinite limit case. Similarly, something we didn't have time to talk about, I mentioned briefly before, is if you take 1 over a limit that goes to infinity or minus infinity, you're going to get 0. But you have to be very careful in the 0 over 0 or infinity over infinity cases. So this is something you're going to have to practice.